you guys. So we have parallels and transversals. Line L and line M are parallel lines. What does that mean? That means that these lines are never going to touch. And a transversal is basically a line that crosses through parallel lines. That's basically it. Now, they do give you the following information. Vertical angles are congruent. They will always be. So that means that angles that are vertical are the same. So if you look at this angle is actually vertical to this angle. So I'm going to write them with one dash, that little line, to show you how these angles are going to be the same. Now we also know that the measure angle BCA, where's BCA? Angle BCA, so this angle is congruent to DCE. So just what we were talking about. Now for the alternate interior theorem, we know that measure CDE, where's CDE? CDE right here. I'm going to put two dashes. That measure is congruent to CBA. So these two are congruent. And if you ever get confused by all these fancy letters, whenever you have the measure angle, we're basically talking about the middle letter. We always talk about the whole thing though, because maybe some people might think it's this one or so forth. CDE means that we're talking about this one. CBA means that we're talking about this one. So with that in mind, we know, what can we conclude for this, guys? We can conclude that these triangles are similar by using let's go up to our notes, using the angle. If two triangles have two angles equal, at least, the triangles are similar. So we know these triangles are similar by the AA, angle. So what does that mean? If we know that triangles are similar, they have the same ratio. So with that in mind, let's use that information to find CE. We gotta find this side. They give you a bunch of lengths already, so let's set them up. We know that BC is over. If we were to use BC, we could make it equal to DC, or BC. If we're going from B to C, we also have to go D to C, to the center. So we know these are equal in terms of the ratio. We're talking about ratios, not amounts, okay? Ratios. And at the bottom, if we know that A and C is also equal, if we go from the corner to the center, we also have to go the corner to the center. So EC. So far, so good. Now let's plug in all these numbers with the length they give you. So we know BC is 5. So we're going to change BC with 5 over. And AC is, where's AC? AC is 4. We know AC is 4, so we're going to put a 4 down there. Do we know DC? Yeah, they give you a 3. So we know that's 3. And we don't know EC. We don't know that one. Or, in other words, isn't it the same thing as saying CE? Basically. So how about we just flip it for the problem? Again, it doesn't matter how you write it. It's just conventions, Let's call it CE. Same thing. Now, what do we do to find the letter CE? Basically, when you're doing ratios, if you don't remember this from elementary, we cross multiply. What's 4 times 3? That's 12 equals. What's 5 times CE? 5 times CE, right? And the final thing, if they're being multiplied, we just divide by 5. So we found our answer. CE is equal to 12 fifths. And that's your answer here. So CE is actually 12 over 5. And that's basically what you do.